This is number 16 on page 5. This is the Hess's law application. We need to find the heat of reaction for this target reaction here. We already saw this earlier in this packet. Maybe that's a popular reaction. We have two gases coming together and forming this larger molecule. Notice the entropy here appears to be decreasing. It's getting more ordered. We went through 3 molecules to 2 molecules, assuming I balanced that right. And yet we don't have the direct access to that information. They don't give us that. But they do give us these 2 other reactions that we can flip around and change the signs and multiply and divide however we need to try to get to this reaction right here. And you can do that because these are standard types of reactions, and so the analogy is it doesn't matter what route you take, the route being these reactions. You could figure out different reactions maybe, as long as you end up with exactly the right substances as you have in your reaction, you can make this work. Okay, and don't forget, this is called Hess's law. Now I take a look at this, and what I need to try to do is use these reactions. We're going to have to eliminate the S8 here completely. We have to eliminate some of the oxygens, and we have to get these on opposite sides of the reaction. SO3, we want to keep that on the right. The SO2 we want to put over here on the left. So it looks to me like my first step is going to be, I have to flip that first reaction around. So number 1, I'm going to change that and flip it around and put the 8 SO2s, and then I'm going to say makes S8 plus 8 O2s. If I do that, I have to flip the sign on this enthalpy term, positive 2,374. Don't forget to change the sign. Okay, now I take a look at this. There's nothing else I can do. I might end up having to do some final refinement here, but let's see if we can do some canceling. Okay, so I'm going to cancel this and this. I have 8 oxygens and 12. So I can cancel, that leaves me with 4 there, 4 oxygens. And I'm just looking at these 2 reactions here. See what I can cancel. Okay, let me rewrite what I have. 8 SO2s plus 4 O2s. I see that. Go to 8 SO3s, and that's it. And if I were to add those up, I'm going to add the negative 3,165 and the positive 2,374, and that would give me a negative 791.4. But that's not really the answer, because in my original equation I don't have 8 moles of this, I only have 2. So I really do need to divide this whole thing by, let's see, what would it be? It's going to be 4. I have to divide all of these by 4, and I have to divide that by 4. Okay, so that is going to give me the 2, 1, and 2 that I need. That dividing by 4 gives me negative 197.8 kilojoules, which I can now see is selection D from our packet. So this is an example of Hess's law.